Welcome to the Learning Lab. I'm Roman Garcia. This is volume 7. This is a continuation of the case that we have, whether we use heat or cold for physical issues or physical trauma. Now, what we're going to do today is we're just following up on our patient, of which I'll just remind the folks out there what happened. About 2 weeks ago, this patient fell, she hit her hip, she developed a deep bruise, she developed a mass or a encapsulated area of blood in the lateral aspect of the hip, and the question that I posed was, do you use cold or do you use heat? Now, the instinct is among the rehab community out there is to use cold. Now, my position is completely opposite of that. My position is you need to use heat on certain types of trauma, of which this one fits that model, where heat is probably the modality that you need to use in order to resolve this issue. And I'll explain and I'll elaborate a little bit more. But before I do that, let me just show you why heat is what you want to use on this particular case and on most cases such as these, or those that appear with the same biological trauma as the case that we're investigating here. Now, why do you want to use heat? That's the question. And why do you not want to use cold? And the reason is pretty simple. You want to introduce energy into the tissue. So if you follow me, just come right over here and let me show you why. This is it. Now, the whole idea about using heat is about increasing the biological activity of the tissue. Because when a tissue, a human tissue, an animate tissue gets traumatized, what it needs is energy, so it can regenerate itself. Cold doesn't do that, but heat does. So the idea behind using heat is to increase the biological activity through the use of heat. If you want to break it down into a mathematical formula, it's very simple. Heat equals increased blood, and blood equals increased energy. I'll go through that one more time. When you use heat, what you're doing is you're increasing the blood vector through the tissue itself. So you're, in essence, you're opening up blood channels through which the body can get its healing elements that are inside the blood into the traumatized area. So heat increases the blood flow to the tissue. It reduces stagnation, which is basically what happens after injury. The area encapsulates itself from the rest of the body. It literally sequesters itself. So you need to penetrate, or you need to overcome that inclination that the body has. And one of the simplest energies that you can use is heat. And you'll be surprised how early you can use heat after a trauma has occurred. I think the current medical mind frame, or the current medical model, is extend the use of cold until you see the bruise resolved, until you see the swelling resolved. And my position is that is incorrect. I think we've been extending the use of cold a little bit too much. We need to start using heat sooner than later. And again, I'll just go through this mathematical formula again, if that's what you want to call it. You use heat, you increase the blood. You increase the blood to the area that's traumatized, and in essence what you're doing is you're bringing energy into the tissue. So what I'm going to do today is I'm going to show you what that energy looks like. And we did that on the first time that we had contact with this patient. So if you allow me, let me come over here and I'll show you that energy as it's flowing. Now, before I do that, let me show you something so you can get a greater appreciation, the difference between energy that's occurring biological and energy that's occurring in an inanimate object. So what I did is I pulled out a hot pack right over here, and I hope you can see this. Now, let me show you what the heat of a hot pack looks like. This is not a living structure. This is an inanimate object. Obviously, it's not alive. Its essence is just a hot pack. This hot pack was 165 degrees. I believe now it's probably like 140, 130 degrees. Let me show you what it looks like on this device. This measures energy flow. Now, the red is heat of a certain threshold that this machine picks up. That's what you see. That is the red. The red are spots on this on this pack that are hotter than its adjacent adjacent areas. So the red means that it's hotter. Again, obviously, this is not a living structure. Now, I'm going to show you what the heat looks like on this traumatized region. But I just want you to get an idea the difference between inanimate heat and heat as it occurs in a biological tissue. It's different. It's not the same. Heat in a human body represents energy that's being used, that's being vectored to a certain area. And I'll show you how it looks now on this case. But you got a good idea over here what it looks like. Now, mind you, this object right here is emanating heat more than a human body does. Human body does not operate at 130 degrees Fahrenheit, which is in essence what this probably is right now. This is probably about 130 degrees. The human body does not operate under those heat conditions. It will burn itself out. But you can see the heat pattern generated from this hot pack. Now let me come over here to my patient over here. Again, we have her covered to protect her identity. This video right now, as you're seeing it, it's 1 week after, exactly 1 week after, first time that we worked with her. And if you saw the volume 7, you would remember that what I said, which is in this situation, in this case right here, the only thing I'm doing is I'm putting hot pack and I'm ultrasounding the area. Now, look at the difference between 1 week ago and today. If you observe, the bruising has resolved quite a bit. This area was all bruised all along here. You can still see the perimeter of it. But it's cleared up in the central aspect right over here, which is where we concentrated the energy delivery. We concentrated right over this mass right over here. This mass right here, this is where she's encapsulated a large portion of blood or degenerative tissue from the trauma itself. It's encapsulated itself right over here. And the reason it's done that is because anatomically around this area over here, you've got basically pockets, potential pockets that can fill with fluid. And when she fell and she struck herself, this potential pocket right over here is called the synovial pouch, engorged itself with blood. This has resolved a little bit, but it still feels hard. It's not pliable. Where you see the major improvement thus far is in the resolution of the bruising itself. It's starting to get a normal skin texture. This still has a little bit ways to go, but let me show you what it looks like under this forward-looking infrared. Remember how that hot pack looked. I wish I would have taken a picture the first time that we used the FLIR on it, but I didn't, but I'll do it this time. What we did do is that we took a picture of the other hip with the FLIR, so you can see the difference. You can see the difference between a tissue that's biologically active, which is what we want, and a tissue that is normal for her. Now, again, you can see that she's showing biological activity more so than the first time that she came over here. Again, I didn't take a picture. I'm going to take a picture of it now so we can compare next time we see this case. This is the X right over here. This is where she has this encapsulated area. You can see it's still pretty, it's inert. There's really no biological activity occurring over here. Again, this is the X right over here. But again, we see that red. That red means, that in essence, that red means energy. The area is biologically active, which is what you want to see. You don't want to see tissue that's very white. Now, obviously, human tissues, if they fluctuate depending on use, on stress, on environmental factors, etc. But in a tissue such as this, you do not want to see it white. You want to see it red. Red means blood is coursing through the area. She's getting matter and she's getting energy flowing through the tissue. That's what that red means. That's what that red is. Again, you can see it fluctuates. The human body works on rhythms, on a rhythm. But again, this is a good sign. What I'm going to do is I'm going to show you. I'm going to show you what the other hip looked like. This is her uninvolved hip. You see how white the hip is. There's nothing wrong with that. Like I said, the body works through rhythm. But you do not want to see this white on a joint that's painful, on a joint that's been traumatized. If you were to put cold on this hip, you will maintain that tissue in this condition right here. That you do not want that. You want blood coursing through the tissues. You want energy. You want nutrients flowing through the area. This tissue right here, right now, is in a healing mode. It needs blood. It needs nutrients. It needs an energy vector flowing through it. It's not producing enough innate energy to resolve this by itself. The energy has to be brought from the environment and brought to bear onto the tissue. Cold does not do that, but heat does. And heat is the simplest energy that you can introduce into a tissue. Again, like I said, the human body fluctuates. You can see how red it is now. This is tissue. This is tissue right now that's biologically active. This is how you want to keep it until all signs of trauma and all symptoms of trauma have resolved. In this patient's case, it's quite easy to measure the trauma because it's observable. You can feel it. You can see it. The visual is the bruising, and it has substantially resolved. The feeling portion of the trauma is this right over here, is this encapsulated accumulation of degenerative tissue. In essence, that's what this is. You can feel this. You can measure this. You cannot resolve this through putting cold on it. You need to introduce energy from the environment and draw to bear on the tissue. So, again, we're going to continue following this case. The important thing is that the first instinct sometimes that comes to you is this instinct that you have to fight. You have to think in biological terms when you get exposed or when you encounter a patient that has been traumatized and you see these obvious signs of stagnation in the tissue. The first instinct is always to put cold on it, thinking that the tissues are inflamed and you need to deflame the tissue. That is not the correct course to take. You will only prolong the patient's condition. It's a paradox. You gotta you go against your first instinct, and that's not easy to do. So you have to think in terms of biological terms, and in essence, in terms of thermodynamics. You have to introduce energy into the tissue so you can allow the normal nutrients vectors to run through the tissue. We're going to continue following this case. This is the second treatment. Our next treatment will be next week, and we'll be able to see obvious signs of improvements. Again, the only thing that I'm doing with this patient right now is I'm introducing heat, moist heat, and I'm introducing ultrasound. Ultrasound provides a pressure wave or a pressure gradient inside the tissues, and I'll be able to physically exert a vector force and force nutrients through the tissue. That's another energy. It's not a thermal energy, but it is an energy. Energy comes in many different forms. And in essence, that's what needs to be done to this tissue. We need to introduce energy into the tissues. And cold is not an energy. Cold basically creates stagnation in the tissues. It's okay to use immediately after a trauma, hours after a trauma. But after that, you have to start thinking in terms of energy and delivering energy and creating movement inside the tissue. And next week we'll be following up on this case again, and we're going to continue following it up until it resolves completely. I do not expect much more treatments needed. But we're going to continue following this case, and we're going to continue using the heat. So for anybody that's watching this video, if you have any comments, please make it on YouTube. I'm anxious to hear from you. Thank you for watching this video. Till next time.